Hi dear students, let's see this question that came in JEE Advanced Paper-1 2019 Physics. The question was from the topic of surface tension, multiple choice correct scheme. The question was not very difficult, but one of the options created slight amount of ambiguity in students. Let us see what is being asked in this question. There are two capillary tubes made of different material T1 and T2. T1 has a contact angle of 0 and T2 has a contact angle of 60 degrees. Now what we are doing, we are creating two different capillaries by joining both of them. That means in first capillary, if you see T1 and T2 are joined like this. This is a single capillary which has been joined by a combination of T1 and T2, and this is the second capillary in which T1 is above and T2 is below. So in this the first capillary, T1 is below and T2 is the top, and in the second capillary, T2 is at the bottom and T1 is at the top. Now, surface tension of water has been given, density and gravity, everything has been given. We are going to insert both the capillaries. That means both this, T1, T2 and T1, T2, T1 and T1, T2 in the water to a different heights as per the options, and we will have to comment upon, whether the to up till what height water is going to rise. Okay. Now the question was interesting because of one of the options. First, let us try to recall the formula of the capillary rise, which is 2t cos theta by r rho g by r rho g, right? Where r is the radius of the capillary. Now, let us assume that the whole capillary was actually formed by the material of T1 only. So if I consider that we have a single capillary formed entirely by T1 material, then let us see what is the height up till which water is going to rise, assuming the height of the capillary is sufficient. So the water is 0.075, surface tension cos theta will be 1 for the T1. R in the question has been given as 0.2 mm. 0.2 mm means 0.2 into 10 to the power minus 3. Density is 1000, gravity is 10. So this 1000 will cancel out this entirely. 0.2 10 will become 2, which will cancel out this. Hence this becomes 7.5 centimeters. Hence, if you have a capillary made entirely of material T1, then the height up till which water is going to rise will be 7.5 centimeters. For capillary T2, if you consider the values, so everything is same, just that theta is 60. So you will multiply this by cos 60, and hence the whole thing will be multiplied by half. So we can say H2 will become 7.5 by 2, which is 3.75 centimeters. That means if we create a capillary T1 which is made entirely of one kind of material, which is T1, then the water is going to rise up till 7.5 if we have allowed the water to rise sufficiently, and same can be said for T2. The height risen by the water will be 3.75. Okay, one more thing, let us try to recall what happens if we do not allow water to rise sufficiently. That means suppose we have created this capillary of T1 and we just insert capillary like this such that this height h dash is less than 7.5. So that means we are allowing water up to rise up till only h dash. So if you can recall that water will not overflow, rather the angle of contact is going to adjust over here. So we can say that, you can see from here itself, T, R, rho and G is constant, 2 is also constant. So basically H by cos theta is a constant value. Constant value. So in that case, what we can say that H is 7.5 by cos of 0 will be equals to H dash upon cos of theta. So this will be new angle of contact. By using this formula, you can find the new angle of contact also if you want, right? So now let's go back to the options. For case 1, that means this case, if T2 is above, T1 is below. If case 1, if the joint is kept 8 centimeter above the water surface, the height of the water column in the tube will be 7.5. Now it is pretty obvious, if you keep this joint 8 centimeter above the water surface, that means this T1 height is 8 centimeter. That means And if you remember, for T1, the water is going to rise only till 7.5. That means the presence of T2 is going to be irrelevant in this case. It's like water will feel as if only the capillaries of only T1, and hence it is going to enjoy and it is going to rise up till only 7.5. So option A is correct. And of course, we are ignoring the meniscus because of the there's a slight amount of water in the meniscus as well. For case 1, capillary joint is 5 centimeters above the water surface. The height of water column raised in the tube will be more than 8.75. Now, in this case, they are saying that if you're keeping this only 5 centimeter above the water surface, then remember, if this is only 5, but water wanted to go up till 7.5, but will it cross this joint? No, because as I told you, the angle of contact is going to adjust. Water will go till 5, but then it will adjust its angle of contact. So you can also find the new angle of contact using this formula, that 7.5 upon cos of 0 is equals to 5 upon cos of theta. So from here you can see that cos theta will become 2 by 3. So this will be the new angle of contact in this case, right? So this is wrong. The correction in this we will come back to this. Let's see option number D first. For the case 2, the capillary joint is 5 centimeter above the water surface. The height of the water column raised in a tube will be 3.75. Of course, in this case, if the joint is 5 centimeters above the water surface, so in this case T2 is below. So in the case of T2, water wanted to go up till only 3.75, and we are allowing the height of 5 centimeters. So water will have no problem and it will rise up till a height of 3.75. So of course this option is correct. Now my friends, this is the option ambiguous option that I was talking about. The correction in the height of water column raised in the tube due to weight of the water contained in the meniscus will be different in both the cases. Now let's see. Of course, we already know that because of the angle of contact, we measure this height, right? We measure this height. Because of the angle of contact, this slight amount of water which is present in the meniscus causes some amount of error, right? So basically, if you can see that this is the top surface of the water, which is in contact with the capillary, and we measure height only till here. So this amount of water, of course, depends upon the angle of contact, because if this is hemisphere, then this surface will be like, if the angle of contact is 0, then this surface will be like this. If the angle of contact is 60°, then this surface will be like this. It will be touching at an angle of 60°. So it is fairly obvious to see that the amount of water present in the meniscus will depend upon angle of contact. If the angle of contact is 90, then the surface will be flat. Of course, this case will not be possible, but I'm just showing you that the amount of water present in the meniscus depends upon the angle of contact, which of course is different in both the cases, right? So if the angle of contact is different in both the cases, so of course the correction in the water because present in the meniscus will be different. But there is a special case because in which the angle of contact can be made same. So let's discuss about that special case. So in case 1, in which T1 is below, what we are doing, we are allowing the height of T1, like this is T1. So we are allowing this only 3.75, right? And above this is T2. So this is T2 and this is T1. So how much is this height? 3.75. We are allowing this 3.75. Remember, I'm talking about special case. So now it is easy to see that angle of contact in this case will become 60°. How? Using by the same formula. 7.5 upon cos 0 will be equals to 3.75 upon cos of 60. Cos of theta, you can say. So cos theta, it is easy to see that it is half. So theta is 60°. Now in the second case, we are allowing T2 of sufficient height. T2 is at the bottom. This is T2, and we are allowing this H to be greater than 3.75, and T1 is above. So you can see water will only rise up till 3.75. Water will only rise up till 3.75, and the angle of contact will be 60°. Now you can see in both the cases the angle of contact has become 60 degree, and hence we can say that amount of water present in the meniscus will be same. Therefore correction will also come out to be same. So in this one particular case, can we say that this thing will become wrong? It will, the option C will become wrong. In general, definitely it is right, but in one special case this will be wrong. Now let's let's see whether we should select this as an answer or not. When you say that this is, when we say that one option is right, then it has to be right in all possible cases. Even in one of the, even if you could think of one of the cases in which the given option is not right, then ideally you should not select that as correct answer, right? When I'm saying that particular thing is correct, then it has to be correct in every possible scenario. Even if there exists one scenario in which that particular thing is not correct, then I will not choose that as correct answer. So suppose I was a student writing JEE Advanced, I would not have chosen this as the correct answer. Although eventually IT took this as the correct answer, they gave this as the correct answer, but in my opinion, this was not the right thing from IIT. They should not have given this as correct answer, or at least they should have given both. Like they should have considered both type of students, those who have chosen AD or those who have chosen ACD. So that's my take. Thank you.